Good morning, everyone, and welcome to this fifth video. Today, we will head right into Unreal Engine, since we finished the console chess project the last time, and have a look at how we can combine Unreal Engine C++ and blueprints to build a 3D chess environment. So, without further ado, let's head right into it. Just a quick disclaimer before we go right into the video. I just wanted to tell you that this video will be a little bit longer than the last ones because we have to go into a new project, of course, and I have to show you where everything is located in Unreal Engine. I have to show you how you can actually use Unreal Engine even with a worse PC than mine, and thus it will take a little longer than normally. So please keep that in mind, and now we can go on with the project progress. As I already mentioned, today will be the lecture of the chessboard pattern, but before we go into there, we will have a look at our current project progress. So we now finished the PlainC section, which is down here, where we introduced the basics and Stockfish to build a console program. We also thought about how to create a fan extraction, and we built our first console game where we can actually interact with the last time. So today's lecture will move on to the 3D part of this course, specifically the chess part. So we start with the chessboard pattern today, and then we will advance to the chess piece spawning. And now you can see it will go step by step. So first we create a chessboard pattern, then we will have chess pieces on the board. Now we can move them by simply clicking onto the tiles we will create today with the chessboard pattern, and then we will smooth this out using the AI move to function. All right, so let's go over to Unreal Engine and show you how to set up the project in general. The project setup itself can be a little bit tricky, so there are two versions. What would be best for you is if you can set it up using Visual Studio to control your Unreal editor. This will be the first part inside this video, and if it doesn't work for you, don't care too much about it. You just need to implement your changes into Unreal Engine, and that can be done by compiling the code manually, which I will show you after this part. So if this doesn't work for you, just skip a little bit forward and I will explain exactly in detail how you can just use your editor or something like that to change files and then include those changes into Unreal Engine as well. Okay? So without further ado, let's head right to the part where we can live control our Unreal editor with Visual Studio. When we first open the folder you can download and extract it, we will find those files in there. And now please listen carefully. If you do this instructions differently, so for example, open up the livingroom.u project first, you won't be able to connect with Microsoft Visual Studio in that case. So what we do first is we hover over the livingroom.u project and simply do a right click to open up the options. When we have the options open, we go under Show More Options, and then under Generate Visual Studio Project Files, we have the function which builds us our project files in Visual Studio. So this will be done very quickly. And now we have a pre-built .vs folder, so we can actually open up this whole project in Visual Studio. To do so, we simply hover over the livingroom.sln, so the solution file, and do a simple double click to open it. Now our projects get loaded and all the dependencies are getting created. And now you can see we already have our project structure on the right here. And as I showed you in the first video, we have those files which we need under the game section living room folder here. When we open it up, we have a source folder and when we open that up, the living room folder appears. Clicking onto that, it splits up in private and public. And when we now click on private, you can see I already included all the files from the stockfish.cpp for you into this project. To now make the project work, so to actually get the right connection to Stockfish, we have to open up the stockfish.cpp once more. And you can see it looks a little bit different than last time. But here is the path once more, and we have to change that to your path. So please do that as we did it last time, or you can simply do it by just going back to your editor folder, and then when you go under source, I have a Stockfish folder created for you in there, and you can now simply choose your option, and for me it would be this. Now if you click onto that, right click it and do copy as path, it should look like this, and you already have the folder you need, which you can then exchange with that part here. Please make sure that you also include those double backslashes, otherwise this won't work. And why did I say this looks a little bit different than the last time? First of all, we have a white string now here, so W string, and that's simply because Unreal Engine can't handle the normal string which we used for Stockfish the last time, so we have to convert it before creating the pipe. All right, with that being said, we should be set up to start our project, and now we can simply move on into the local Windows debugger section down here, and if we click, it will create our Unreal Engine project for us in quite a while, so I will skip that for you, and I'll see you when the project has opened up. Once the project is built and Unreal Engine has opened up, you should be in such a screen now. So you can see the scene already in there and your outliner on the right. But what I want to show you first is when we go back to Visual Studio, you will now have this ready sign down here. And what you will also see is in the upper corner here that we could stop the instance which is attached to Visual Studio or pause it or whatever from Visual Studio itself. So we are now attached to Visual Studio, and whatever we code in there would be changed in real time in Unreal Engine. All right. I also want to show you what exactly did change in our folder here. So let's go to the living room folder. And we had already those .vs, saved and intermediate, I think. And now we have also the derived data cache and binaries. So if you want to zip this project file and give it to someone else, you can simply delete those folders here, which I just clicked onto, and they will create it on the startup for everyone again. So those are your temp folders, and you can't do anything wrong if you delete them, except for the saved folder where your screenshots might be stored in, so make sure to save them before you delete them. But if you want to zip them, you can safely get rid of those. You can always recreate them from those folders which are not marked at the moment. Hopefully you were able to already control your editor by using Visual Studio, but if that weren't the case, don't worry, I will just do this part for you so you can also work with your manual changes inside the editor as well. So if you have to do it manually, just click onto the livingroom.u project and then double click onto it to open it up. That will create the intermediate and saved folder for you. And it will also ask you if you want to rebuild the project, and you simply click yes here. So the project will be built for you, and the only thing which you will see in a second that is different than compared to the Visual Studio option is that you won't be able to control the editor using Visual Studio, of course, but instead you have to do the live coding here, which I will show you when the Unreal Engine opens up. and you have one folder less than the other version, which is the .vs folder. So you can already see the binaries have also been created, intermediate saved binaries. Now we are only missing the derived data cache, and that will be done in a second. So we can simply click on show log, and we will see that it currently builds our Unreal Engine project. And once this is finished, I will come back to you and we will do it together. When the build process is finished, you will see this as your starting screen. And how can we check if we are able to implement changes which we do in the file and then also refresh it in Unreal Engine so it works with those changes? So we can just open the content drawer here and go to content and then maps. And now we're currently in the living room map. Let's go to the chess map where we will actually be for this lecture. And you can see here is nothing in the middle located. So no tiles currently, no checkboard pattern. And we can check if everything worked by going back into our Explorer. And this Explorer should now have 4 more folders. As I already mentioned, it should have intermediate, saved, binaries, and derived data cache. The only one you will be missing is the .vs folder, since we haven't constructed a Visual Studio project. All right, from here we can go into Source, Living Room, Private, and then we can open up the chessboard.cpp by simply right-clicking it, open with, and I will open it with Editor, so you can actually see that I don't need Visual Studio at all for that. Now we should go into the function inside here, where the field location.reset is located. So in the construct Checkboard-Pattern function, and then add a line behind it, which states light tiles, do an arrow, and then add instance. And now we simply add a transform, so the standard transform, and that should do the trick for us. Don't worry too much about this line. It simply will add one tile to our light tiles array, and we will see what it changes in a second. So make sure you save that. And now you can minimize this window and go back to your engine. And you can see nothing has changed here. So it didn't work yet. What we can do though is to go here, and that already shows us the recompile and reload function. And then we hover over it and click onto it, and it will start the live coding for us. So it will check every file we modified and rebuild it for us. And now we should see that there is still nothing, but once we change the map, so just go to the living room map, let it load for a bit and go back to the chess map, you will see that the tile is located in the middle now, and we know that this code is working. So please make sure now that you delete this line again. So simply open up the file again, save it, go back, press live coding once more, and the patch is created for us. Now we can go back to the living room map and back to the chess map, and you can see the tile is no longer there. So that's how you can set up everything without the option to control it via Visual Studio, but it will work the same as I will show it to you. Except for you have to always press that when you change your source files, okay? Right. All right, back into Unreal Engine. So first of all, you might have some FPS drops. So how can we change that? First of all, let us show the FPS. So I have 40 in here now, and my PC is not running on turbo mode, I think. So let's go into turbo mode. All right, that should change a little bit at least. And if you still have problems or don't have such a mode, I will just allow myself to have more FPS than I can show you. So let's do something like 120. And now you can change that by simply going onto this burger menu up here, then screen percentage, and now custom override, and just turn it down. Then the resolution here will get less good, but you will get an increase in FPS very, very quickly. And what you can also do is going on to the settings up here, going on to engine scalability. And as you can see, I all have that at epic. So when we go into low, I already reached my 120 FPS, and it still doesn't look that bad. Of course, there are some details missing now, but that shouldn't be a problem. And if this still doesn't help, you could also decrease your material quality level. So let me go back to epic and set my material quality level on low. So now I have 65 FPS, and now when I click onto low, I'm already going onto the 70, I'd say. So it changes a little bit and doesn't lose that much of a detail in there. All right. Then let's go back to high here and start with the scene overview. So you haven't seen that scene right now. I can also go back to the screen percentage and do my, I think it was 70, custom override out there. You can keep that, but I just wanted to show you if the editor is lagging or something, this is the quickest option to get rid of those FPS drops. All right, now in this scene, we have the ability to move around. You can already see when I hold down my right mouse button and press WASD, I can move around in the scene. So let's do the movement patterns once more. That's the movement, or only if you hold down the right mouse button. Look, now I press WASD and nothing happens. So please hold down the right mouse button to move around. Then you can also move up and down. You see I press Q and E and it doesn't change anything. It does change something up here. But when you hold down the right mouse button, you can go down with Q and up with E. So straight up, straight down with those two buttons. All right. Now, one more thing is how you can move around faster or slower. So when you use your mouse wheel to scroll out very fast, then you will move way, way faster. You can see that my camera speed changes up here. And now I can move very, very quickly, but I will miss all my targets with that. So when I scroll down a little, I'm very, very slow. So you have to always figure out how to best move around. And if you don't see your scene anymore, simply click onto something in there. So for example, the ceiling. Let's turn around. I don't see my scene anymore. And then simply hover over the scene and press F and you will jump directly towards it. And that's way, way easier to move around. So for example, you want to have, let's say, the TV in focus, simply press it and you will move there and can have a look at that. Great. So now we have something in there. That's the dartboards we will create later. And you can already see a chessboard here, but that's not working at the moment. We haven't done anything to make it work. We haven't started the scene. Then we have some cameras in there, which you can use to create a trailer out of that room. And yeah, that's it. We also have some light where we can toggle the lights on and out because I implemented an interface. So you can see there is currently, I think, no light. Let's turn it off. Okay, there was light. And you can simply change that by clicking on to turn light off or turn light on and toggle the modes there. This also works for all the lights. So turn lights on, turn lights off. So all of them are out now. And that is how we can change the lights in our scene. Perfect. Let's start the scene for the first time and see what happens. So now I'm in the scene and I can move around freely. And as you can see, we have the chessboard here, but it doesn't start, right? So if you wanted to start, we can do one simple thing, and that is get out of the scene first by pressing the escape key. And then we click onto the chessboard. Now we move that down a little bit and go on to the edit the blueprint part here. And this will be your first time seeing blueprints, and I'm already at the right position, so maybe you have to scroll in a little bit. We have some events here where we trigger something. I will explain that in detail a little bit later. And you can see we're missing one connection here. So you don't have to put anything in there, just connect this two, and make sure you already changed your Stockfish path, otherwise you will get into an infinite loop and you can't close the window anymore. But if you press play now, we already have a finished and self-playing chessboard, which moves against itself, so Stockfish playing against itself, and we will create that so we can interact with it as well. Let's have a look at the living room itself. So let's get a quick overview. What are the lesson relevant parts for us? We have chess, we have darts, and then we have your tasks in there. So chess will be a fully functional 3D chess based on our previous console program. Then we have darts, which will be a working dartboard. That's your task in the semester, but we will create the darts together, so you actually only have to check the collision and then determine which part of the board got hit. So maybe you got 20 points or 5 points. That's the part you can decide on. Well, then let's go to the chess party overview. The chess party overview is quite simple, and we have, first of all, always in Unreal Engine game relevant blueprints. Those are the game mode, the game state, and the game instance. Let me quickly enable the laser pointer here. So what is the game mode? The game mode is something which is used for global initialization and storage of level dependent values. Very, very, very important is this word level dependent values. Why is this the case? Because the game mode only consists for your current level. So you can change it for each level you open, and it won't save any value when a level change is happening, okay? That's what the game instance is there for. We don't need it at the moment, but in theory, this is the module that opens up when we press play in our editor. And then this gets created and it will be there until we close our game, okay? So this is where you want to store all your game relevant information. I usually do that in this way, that I use the game mode to store my level dependent values. And when I see, or when I want to change the level, I save all of those values, which I will need later, inside the game instance, then do the level switch, and then reinstantiate the previous game mode basically. So I can't change that the game mode is created from scratch, but I can then use the values out of the game instance to actually load my previous saved values back into the game mode, so I have everything in that current level once more. You can also do that in the game instance, but that's what I usually do. I only use the level dependent stuff inside one level, save it to the game instance, and when I change the level, load it back into my next game mode. Then we also have the game state in here. And the game state is a little bit tricky to explain because it doesn't have that much usage in a single player game like we will create now, but in a multiplayer game for sure. So you have to think of a multiplayer game like you have one game that has a game state. And then we have some player states. And those player states are relevant for one player, whereas the game state is relevant for the whole game itself. And then the game state communicates with the player state and updates the player state based on the game state, or the game state gets updated based on the player state. So imagine someone dies, the game state gets updated. So the game knows that the player is dead, and maybe if it receives a hit onto that player, which should not be the case, it can ignore that and doesn't change anything. All right? Good. So then we have the chess party relevant blueprints, which is the chessboard, the chess tile, and the chess piece. So first of all, I told you we will create a chessboard, and this chessboard will then consist out of chess tiles. You might wonder how this works. So instead of simply creating a texture, we will actually use 3D objects to create our tiles. Why? I can explain it to you exactly. It is way easier to use 3D objects which we can then use to click on later on to make our pieces move towards it, instead of using always storing those information inside the pieces, so we can simply extract that from each other, and then we have a very, very good schemata of one chessboard that can do nothing, one chess tile that is used to determine the position of a chess piece and stuff like that. And then we have the chess piece, which is in this case a parent class of all chess pieces, and it contains the whole logic for the chess piece movement. So it knows how to jump, it knows how to castle, it knows how to move or attack something. That's it. So that's our relevant blueprint in there. Then we have the chess party relevant C++ files, which is the chess AI, which you already know. But instead of the chess AI handler, which we had before, it's now a blueprint library. And this blueprint library allows us to use those functions inside blueprints by simply connecting them with the arrow you've seen earlier, so the white line. And then we can use all of those values from there very, very easily. Then we have the chessboard that contains all functions that are directly connected to the chessboard blueprint inside the engine, such as create tiles, moving from one tile to another. So we have all our tiles stored in there. And then we have the chess piece, which is a helper class that allows us to set then the color of the chess piece. And that's it. Because we will spawn chess pieces without any texture or stuff like that. And if we wouldn't have a helper class that allows us to set the material as we want, it would not be possible to determine which color we want to spawn on the field. Perfect. That's it. Before we head over to blueprints, let's have a look where this is located in Unreal Engine first. Right back in the engine, we already see I changed my scene back to the living room map to show you exactly where those stuff is located. But I guess before we do that, I will quickly walk through together with you once more where we can do stuff in the engine. So let's click onto that chessboard here. And when we click onto the chessboard, you can already see it opens up in the outliner. And that is basically like you know it from any other program, where we can click on the stuff that is located inside our scene. We can then move it around by simply dragging here. And as you can see, it doesn't move continuously, but we can change that by simply clicking onto that grid here. Then it doesn't snap to the grid anymore, and we can move it freely as we want. That's one of the first parts. We can also change the snapping, which we want to have. We can change the angle it rotates. So if you want to change the rotation, just click here. Then you can move that and turn it around as you want to. You can also scale it. If you hold down the middle of it here, then it will scale from the middle. So all of the axes are getting scaled. And if you only hold one of those, it will only get scaled in one direction. And you can see it already has quite a, I'd say, unuseful scale. So we can change that quickly back. And then if we want to change that, we simply deactivate the snapping, and now we can scale it way, way more precise. So that's one of the first parts. All right, let's move that back to the moving part here. We can also change that by W, E, and R, but for now I will just do it here because I think W, E, R for rotation, scaling, and transform is not that kind of intuitive. Great. Then I always also want to enable the snapping grid once more, and that's it for now. All right. So this is the first part, how we can move stuff in the end. What we want to know now is how are blueprints built and where exactly are they located. So let's first find out where they are located. If we open up the content drawer down here, we have our content folder. And this content folder includes all the stuff we added to our scene. So in the cinematic part here, there's nothing more than a handheld shake, which you might include if you want to have something like a movement in your trailer. So that's why I added it here. Otherwise, the interactive media folder is the most useful for us. So we skip it for now and have a look at the living room folder. And the living room folder has some animations in it. You can see we have the animation of such a cradle loop. We can also have a look at that, and you can see it's nothing more than that. It's just simply moving some, let's say spheres around, which can hit each other infinitely. So that's the cradle loop. And then when we go back to the content drawer, we also have a fan blade rotation and stuff like that. So that's where the animations are located. Then we have a blueprints folder, which has the living room character in it, a game mode, which we now know what it does, and the player controller. That's not relevant for now, but this is what we use for our blueprint, for our living room here. And you can check that by clicking down onto that arrow here, and then just have a look at this. So our project settings is the BP_living game mode, and we can override it for this level specifically when we change it here. So we could, for example, select another game mode base class, such as our game mode chess, and then it would work inside this level as well. But we will leave it at the living room game mode because that's already the correct one. Let's go back to the content drawer. Then we have the player controller, which simply controls the movement of our player and the character itself. I can quickly show that to you. It looks like this. So we just have a camera and some arms attached to it. And we also have a collider. And you might wonder why this collider is so small. I changed that because otherwise you get stuck in some corners of the room because the collisions of some objects aren't set up correctly, and it's quite difficult to change that. So we can simply do this workaround here and just change the collider size of our character so we can move around and don't get stuck at all. Then the next part is that we have a look at the materials. And the materials are in there, and you can see those are quite a bunch, which is not necessary for now, but for example, you can see this master here is done doing visual coding. So you have something like the base color, which is then combined with a parameter of a metallic value and stuff like that. And this is how we can create materials. So if you know shaders already, or if you know how to set up materials in Blender, it's quite familiar for you how this is built up here. The next part we can have a look at is the meshes. And the meshes are split up into building, interior, and skeletal meshes. And the building meshes are simply the walls and stuff like this. And as you can see, they don't have a texture. So this is quite a large piece. So let's move out a little. And here we have the world grid material, which is the standard material, which is used for all our meshes. And we can check the collision when we go over here, and then we could add something towards the collision. Otherwise, it's still totally fine. So this is just the mesh we could import into the scene. And when we want to know where its collision is, currently we can check the simple collision and there is none currently. But if we check the complex collision, you can see there is a collision set for us. And thus we can use it also together with colliders inside the scene, and it would also register that the ceiling is not something you can walk through. Then we have the interior, which is also just static meshes and that have some materials set on them. Let's check that out quickly. So the apple, for example, has the world grid material, and we could simply change it by, for example, adding the, what could we add? Let's go with something like the dark metal gold. And you can see the apple is now made from pure gold. So that's how we could change the material. And you can see it's also very easy to change that if you want to change your material here. Then the next part is skeletal meshes, and skeletal meshes are all those things which can move around. So those always include a skeletal mesh, a physics asset, and the skeleton itself. And I don't want to go too much into detail, but they are basically meshes which have some extra functions like bones into them. So if you click onto the skeleton, you can see we have a root bone, we have something like a ball which we can then rotate around, for example, around this bone. And that's how we can use those skeletal meshes to create an animation later on. Then we have the plans section, and the plans section simply includes some plans which have materials and textures. And I haven't spoken about textures yet. Textures are just, you can include a PNG file, for example, in there. And this is how it looks like in Unreal Engine then. And you have different settings, such as if you want to use sRGB or not, to make it look more colorful, stuff like that. So this is how you could set up your textures inside the engine. Then we have the textures itself, and you can see we have the images here, the pictures and stuff like this. So this is what we have inside the living room. The only thing that gets relevant for us and only one time is the living room character, because we have to click onto that. Sorry, I'm already in there. I meant the living room character here, and then the event graph, my bad here. And then we have the two functions here, which are currently completely empty, and that will be the physics dart logic and the projectile darts logic, so 9th and 10th lesson. Great. The next part we can look at is the maps, and we have 3 maps in there. We have the living room map, which you can already see in the background. That is our living room map. Then we have our chess map, which is looking like, let's don't save it, like this. So that is which we will start with. And as you can see, as I mentioned earlier, there is no checkboard pattern in there. So we will create that together using Unreal Engine C++. And then we have the open world map, which currently looks like this. So that is one task of your semester project this year, to actually make something cool out of it. So basically create your first open world, and trust me, it's not as difficult as it looks. So if I just go back to the living room map, let's go back to the living room map and go on from there. And we have now a look at the folder once more. We have a chess map build data. So that's where you can, or no, that's where the building of your lighting and the paths and stuff like that you included in your scene is located and saved. And this will be done for every map. And here we also have some instancing, because the open world map consists of, if I go back there, consists of different sectors, as you can see here, and they are streamed. So we have some HLOD instancing here for each of those, which will then be combined in this file here. All right, next part is the standard first person. Nothing special about that. You can simply add that by clicking on the add button here, then add feature or content pack, and then you could do the first person, which I included here, and then add to project. Then you will have the exact same folder as I have here. And this will just include some blueprints. So the rifle, the first person character, which might look quite familiar. So let's click onto it one time and go to the viewport. I guess you know now where I have my character from, right? And then we can go back into the standard first person. We have the first person arms, which are including animations. We have the character in there. And this character has a mesh. As I already mentioned, it can move around. So this also is a skeletal mesh, which has a skeleton, of course. And we have the normal mesh, the textures, and so on in there. Nothing special. Then we have a weapon. We have an input, which we can then use to determine what we have to do. So the default input, let's have a look at that. There are mappings included, so we can jump, move, and look around. And when we go back, we also have some part of level prototyping that just includes some meshes, because we have included the whole first person here and the first person map, which you can download as well. So far, so good. Let's go to the most important folder, the interactive media folder. We have the chess folder in there where everything is located, which is relevant for our 3D chess project. We also have the self-playing chess project. So this is what you can see already on, sorry, I have to change the map first. On the living room map. This is what you can see here. So this logic is purely built by using blueprints. So no C++ code is at all. So you can actually see how a function would look like in C++, Unreal Engine C++, compared to blueprints. Let's go back there. So the self-playing chess includes our board and the self-playing chess tile. And it includes the chess pieces, which you can already see here. And that's it for the self-playing chess. Then we have the darts folder in there. The darts folder simply includes our blueprints, so the physics darts, the dart and the dart cabinet. Then we have some inputs, which I already added. So I grab in this row input, so we can actually interact with the darts later on. Some materials, some meshes, some textures, the arrow rifle, which is located here. So you can already try that out, but it won't work currently because the arrows are okay. Let's try it out. I actually don't know what works in your project currently and what doesn't, but it should just fly through. So when I shoot here, you can see it just goes right through the ceiling. I was a little confused here because I pressed shift and I just forgot that shift just dismounts the gun and deletes it basically. So that was what was happening here. And then we have some problems with the texture streaming tool. So I will just change my screen percentage a little and get rid of that. Let's go to 50. I think when I do the recording, it struggles a little to keep the FPS up. So maybe we'll even go to medium here for the ancient. Yeah, okay, that's better. Now we are in a green area again with the FPS and it doesn't lag anymore. All right. Let's go back to the content drawer. Then we have all of this stuff I already mentioned. We have a dart weapon component, which is used for that one, and a living room character that has specific movements that will be shown in, I think it's the 10th lesson. So I will show that to you then. Then we have some lights. There is the interface where we can interact with. I already showed you we can turn on and turn off the lights. And yeah, that's it for now, I guess, with that part. Then we have the open world. That's simply the texture. So your open world is located down here. And I want you to build something when you move through that frame, you can get into your open world. So once you've done that, just simply use another texture for the frame here. We can open that up. Here we have the components. So let's go into the blueprints a little. Here is the frame. And when you change your materials here, especially this material, it will change the image which is inside the frame. Then we have the self-playing chess, which I already mentioned, and the chess itself, which is containing the assets. So all of the chess assets, the chessboard, the chessboard tile, and all the chess pieces. Then we have the blueprints, which are a board. The board itself you've already seen. The chess tile will be what we add today. Then we have some custom macros and a pick board just to make it a little bit cooler looking. Then we have the pieces, which are also blueprints, and those contain the logic. for the movement of each of those chess pieces. We have the game mode, chess, which starts when we start the level and will also initialize our spawning of the figures and the chessboard itself. And then we have the game state, which I already mentioned, and the player controller for our chessboard, which we will need to use for the clicking, so we can actually click onto the chess tiles. And then we have some widget, which is the UI option Unreal Engine offers you, and that will be used to then determine what piece you want to promote to. So once the pawn reaches the other end, you will see that widget popping up and showing you which piece you want to pick from. Then we have the materials, of course, where we can switch the colors. This is what we use for the wooden chess pieces. And we have some textures. Then we also have some Niagara system, which is some kind of effect. You might have seen that already. The destroyed effect might have already been visible. Let's try to make it a little bit bigger. This is what will be triggered when a chess piece is captured. And we also have one more, which is the despawn, which you haven't seen yet because that only happens when a promotion is done and then the new piece gets spawned. So it just looks cool. Then we have a structure, which is similar to a struct I already explained, and the enumeration for the states, which we already talked about. So the enum is also the same here as in C++, but that's it for the project for now. All right, let's go back to the presentation and have a look at what blueprints are actually and how we can use them. All right, so quickly a reminder, we talked about the blueprints. You know where the game mode is located now, you know where the game state is, and that we don't have a game instance inside our project. Then we have the chessboard, the chess tile, and the chess piece. You've already seen that as well. Then, which I haven't shown you yet, is the C++ files, but we will do that in a second. But before, I quickly want to go over what blueprints are and what they are good for. So blueprints are node-based visual programming nodes. So we can create code by connecting nodes together. And this can only be reached from code when a C++ class is set as a parent. I will show you exactly what that means later on, but keep that in mind. Then we have also the shared programming experience between designers and programmers, and I might have to explain that a little bit. So when you are a really, really good programmer, it can be quite a challenge to tell someone who's mostly using design parts or stuff like that, how your code is built and how you can actually interact with that. What Unreal Engine offers you together with blueprints is that you can have a code that is visually understandable. So, for example, you can only connect a Boolean variable with a Boolean variable of a function. So this is done by using colors. So a Boolean variable will be shown as a dark red, and you can only connect it to a dark red dot inside the function. And that's it. So you can share the programming experience between designers and programmers. Then we also have some troubles with blueprints because they are saved as binary code. And as you can imagine, it's quite hard to version control such binary code. So what you can do is open up the two versions beside each other and then see what have changed. But it's not as easy as, for example, reviewing code, plain C++ code on GitHub or something like that. So blueprints are really, really good to actually be able to talk to designers or people who don't have that much experience with programming, but they are extremely hard to version control, which is the trade-off you have to do. And this is how a blueprint is typically built up. So when we open the blueprint, let me quickly switch on, okay, right here. Let me quickly switch on the laser pointer here, and the blueprint we opened up here is the chess tile blueprint, which we will use to spawn the chessboard pattern later on. Now we have the section with the blueprint options, so we can save something, we can compile it. That's two things we always do. So we simply click onto compile and then save it, and that is what we do every time we changed anything in there to just make sure that everything is saved and done. If you have a star behind your name of the blueprint, it means it's not saved, and the compile shows you that it isn't compiled also because it has this yellow question mark in there, which changes to a green tick mark once you compiled it. And you can also see that we have some other unsaved parts here, which is down there. And that means we have not saved this blueprint. And you can save it either by clicking onto there or here. The only difference is that you will save everything that is currently not saved when you click here instead of here. Then we have the differences. So basically you can version control it here. And let's quickly jump over that. We don't need that. We have the class options that is relevant for us. So we have the class settings and class defaults. And this part here is not class relevant, but component relevant. So we just clicked onto the tile here. So this is the section where we can have our blueprint components. And this tile component now is located at this position, has this static mesh and this material. When you want to change it for this specific component, you can change that into here. And if you want to change to another component, simply click onto here, for example, the debug text, and you can change that location and rotation as well. Right, let's go back to the class options because one thing is missing here, and this is what does the class options actually do. So we have something which is the class settings, and that includes which parent class we use. And you can see the parent class is chess tile here. And this is what we actually derive from. So this will be stored here in our class settings and class defaults, and we can change it in there. Then we have the play button, but we also know that this is located over our scene viewer. So we can do that in here as well, but I usually don't do that. Then we have our blueprint functions and variables. And here you can see what I meant with, you can only combine, for example, in this case, a blue dot with a blue dot, and that makes it quite easy to understand how you can connect those two objects together and build a code out of it. Then we have the variables down here. So the thing we are currently in is called the event graph. And the event graph contains all the logic for this specific blueprint. We also have an event begin play in there. And this begin play in there is always triggered when the game starts. We also have the event tick. And the event tick is something different than the begin play because this is only triggered once your level starts, and the event tick will be called every frame. So make sure you don't use that too often because that gets quite imperformant very, very quickly. The other parts up here are the viewport, where we have our 3D visualization of what we actually built. So you can see what the tile would be looking in there. And the construction script, and this is something like in Unity, for example, it's the awake. So this is, no, actually there is nothing like this in Unity because the construction script is something totally new to you. And this is called even in the editor. So when you change something in there, it will already be done inside the editor and you don't have to click onto play. When you click onto play, this event is triggered. This whole part which you put into the construction script here will be called every time you recompile your blueprint or you move it in your scene or stuff like that. So also please make sure that there are no arrays inside of that, because they will get filled indefinitely and you will quickly go out of memory very, very soon. Then we have the function sections down here. So back to the blueprint functions and variables part. We have the construction script, which I already mentioned, and some extra functions which I just added. Some macros and the variables, and you can see what I meant already. So the field name, for example, is a string, and this string has a kind of rose, I'd say, or pink color, and you can only combine those two, for example, very, very good together, but not together with the chessboard, which is of the class BP_chessboard. So far to the overview. Let's go back into the engine and have a look at how we can actually use that inside the engine. Now you know how to actually view a blueprint, and I want to show it to you live once more, of course. And this is when we go into blueprints. Let's go on to board, chessboard. And now we go to the event graph. I already opened up a function here, but that isn't necessary. So you can see we don't have any begin play in there, but how could we add one? So if you ever delete something, you can always do a right click and it will open up these all actions for this blueprint. And now you have two options. You can either select them by opening up this stuff here and just selecting them by clicking onto it, or you just, for example, click into there and type in event, and then you can, for example, do event begin play. And here is your event once more. And now you can actually just hover over this execution part here, so the arrow, and pack it here, and it would call parse when at the beginning of each play. So this is how we can get that in here. Let's quickly do an event tick as well. You can see already that this works, and it has some delta seconds. So this is the time which was used until the last frame, and yeah, that's the thing you can add here very, very quickly. This is one function, so this is one custom event we can add here. That's simply done by doing a custom and then add custom event, and then you can name it, and that's it for now. I don't want to get deeper into that, but what you can see here is that we already built something up, and this is an event which then calls multiple functions, and in this case starts the initialization of our chessboard. So first of all, we destroy all chess pieces, then we pass our current fence string, and you know that already. That's the function we wrote together, the parse fence function. And now we take the board, spawn the chess pieces on board, and once this is completed, we cast to the game mode and tell it start next move, which is another function, or actually event inside the game mode, which we can then use to start the next move, so player change and stuff like this. Great. What does the construction script do? You can already see we have the construct chessboard-pattern in there, and it doesn't do anything. But we combined two things with it, and this is the light tiles. When we click onto that, we can see this is the light tiles, and this is the dark tiles, and we can't use that for anything, right? But if we have a look at our components section up here, we can see that we actually have light tiles included in there. And that is a so-called hierarchical instance static mesh component. And this hierarchical instance static mesh component simply is kind of array which you can use, and that can only present you this parts here. So it can only show you, or it can only construct the chessboard tile meshes, and you can set a material towards it. As you can see, the dark tiles are using the dark material, the light tiles are using the light material. And this is already one function we just created by code, or which we will create together by code in a second, and that will be code in the construction script. So To show you what it does, you just have to wait for a little second until I explained it completely. Then we have the functions down here, which we can open up by simply double-clicking onto it. And you can see this is, for example, the convert field to index part. And yeah, that's it. What we can do with the functions here. Macros look like this. So you have an input, you have an output, and macros are actually pretty cool because we can determine what we want to call at what, yeah, how to say that. If we want to have an executioner or not. So in this case, we want to have one, and we can change the inputs here. And that's the options we have for a macro. Then the variables, for example, the legal moves in there. And the legal moves are just a variable type string. And we checked array in there. So when you click onto this small arrow down here, you can open it up and change it from single, array, set, and map towards what else you need. All right, so far so good. So this is how the blueprint looks inside. Now I already told you we have the compile part up here. I won't click onto that because otherwise then my stuff gets compiled, which I changed, and I don't want to change anything in there. Here would be the differences. So when you have revision control, you can view it directly in here. And those are the class settings. You can see the parent class is set in there. We can change it very easily by just clicking onto that small arrow here and changing it into whatever we need. And that's it. We could also add default namespaces, but we will skip that for now, so don't worry about that too much. The class defaults are pretty interesting because everything which is inside the components and which you can pick from will be listed in here. So all of those variables down there, which are not that many at the moment, are listed in here, and you can simply have a look at them. You might wonder where those variables come from, because those are all variables, and they are not listed in here, right? So they come directly from the code, from the C++ code, which I will show you in a second. Yeah, and that's it. So this is what we can do in our editor and inside the blueprint editor, and we can, yeah, create simply code by just connecting it together with stuff like that. All right. So I suggest we have a look at our chessboard pattern first and do the other part next time. So how can we actually spawn something? How is the checkboard created and set up with defense string? And yeah, I think that's the best part because we just need the chessboard for now, because everything we need in there is inside the construction script, and then I will tell you next time how exactly this game works. We can quickly jump back to Visual Studio by simply clicking onto the checkboard pattern and double-clicking it. It will open up the chessboard.cpp for us. And I already showed you where this is located, but when we click onto the Solution Explorer, you can see we have the C++ files in there. How can I create those? Let me quickly show you this as well. When you go back into the engine and you go in the upper section here, which includes all the options we have for the editor in general, we can go under Tools, New C++ class. Then we can select which parent class we want to derive from. In this case, I just check none. Then we go on to next, and then we have the option to tell whether this class type should be public or private, and we can decide which path it should be in and the name of the class. I won't do that now, but it would then pop up into here and we could change it. So that's all we need to know for now. So as you can see, there is no function implemented currently, and that's correct. But what we can see is the construct checkboard pattern, and we already have our uHierarchical instance static mesh component in there, which is used to construct checkboard pattern. And this might look familiar to you because when I open up the chessboard once more, that's exactly this function here, right? We have the light tiles, so the U hierarchical instanced static mesh component, and the dark tiles. Don't mind the U in front of it. The U in Unreal Engine simply stands for an Unreal Engine component. You will also see we have some changed, how to say that, types in there. So a string is no longer a string, but a F string, and so on. And that's how you can use that in Unreal Engine. So let's go back to the code. Inside the code, we have the chessboard.cpp, and that includes the header chessboard.h. And I will quickly open it up as well. So underneath the public section here, we can click onto the chessboard.h. And you can see we include some files which aren't familiar for you. And those are the core minimal.h, gameframework.actor/actor.h, and some other stuff which I just added towards it. This is the component we need to add, so we have to include that one as well. And the chessboard generated will actually get created once you click onto the new C++ class. Then those three things are already included inside your file. The pragma ones up here we used before, but I haven't explained that. The pragma once ensures that only one of those header files is available at the moment and not two of them. Then we have the chessboard, and the chessboard itself has the A in front of it, means it's an actor. So the chessboard derives from the actor class. And then we have some U properties. The U property is what you have seen on the right side. So we have a map of a string and a subclass of chess piece. How does that look? Let me quickly show it to you. You can see that under class defaults. And now we have the chess piece classes here. And this might be familiar to you. So we have the map and we have the as keys K, Q, B, N, R, and P. And those are the chess pieces on the board. And they are mapped towards a blueprint, which is, for example, the king, queen, and so on here. And this is how we can create the map. Then we have, let's quickly have a look at that once more. We have the fields, which is currently empty, and we have field locations, which are currently empty as well. We have some colors, and we have the set offset and the tile scale together with field letters, and we can see the field letters are predefined A, B, and so on until the letter H. And you can find that exactly in the code as well. Here is our fields, a map from strings to a chess tile. Then we have the map string to a vector, field locations. The material is a material instance of a light color, material instance of dark color. Set offset is simply a float that doesn't change anything. The vector tile scale, which is just a 3D vector, and the property, the array, which contains the field letters, which you've already seen. And you might wonder why we had the field letters in gray here, and all the others are changeable. So you can see I can't change anything in there, and that is simply because I changed something inside the U property here. So the U property defines what you can do with this variable. And in this case, I tell it it's only blueprint read only, and all the others are blueprint read and write, so you can change that inside the blueprint. Then we have visible anywhere compared to edit anywhere. So edit anywhere means I can change it also in the editor. Visible anywhere means I can just see it in the editor. And then we have some category chess, and that might be a little bit unfamiliar, but I can show it to you very quickly. When you click onto inside this area here with the right mouse button, we already found out that it opens up the actions for this blueprint. And if we now put in chess here, you can see there is a whole category called chess, and that includes all the functions we added towards our scene here, towards our chessboard here. And that's very, very good. So we actually find it in the same namespace, not exactly like a namespace, but we can simply search for chess and this category will pop up instead of just being listed under utilities or stuff like that. We can find it very, very quickly. And what you can also see in there is all the variables inside the chess category. And that's exactly what we did here. So we can now get the chess piece classes, we can get the set offset, we can get the tile scale. And what you can also see very, very quickly is how those colors match towards each other. So we already found out that this pink part here means we have a string, and the purple part behind it means in this case we have a class, and this class is not just a class, but a class reference. So we can only pick things that derive from that class. This one is just material, so it is blue, array of strings. Here we have a string combined with a vector inside a map. Here we have a string combined with some fields, so those are actually instances of fields. We, again, a color, so that's it. And then we have the vector, which is yellow here, and green, which is used for floats inside Unreal Engine. So you can quickly distinguish them from each other. So far, so good. What you can also see is that I can change the tile scale in there, and that's exactly what I mentioned earlier. Great. Then we have the begin play. So whenever we put something into there, it would be the same as using begin play event inside the engine. So it's the same as we go back to the event graph. You can quickly close all the tabs to the right by right-clicking onto the event here and then close tabs to the right. Then you just have that. Let's do an event begin play. And that's the same as here in our code. And that's it. So then we have the calculate feed location. That's just some functions we have included yet, but you can see it already inside the chessboard calculate field location, which is dependent on the chessboard. Then we have the virtual void tick. So this would be the event tick inside the engine. So let's quickly add that to here as well, event tick. So those two are always inside your C++ code as well. And then we have the functions, and the functions are, in this case, blueprint callable, and they have the category chess. That was what you can see here. So when I enter chess, we have the functions in the upper part, and when I just close those utilities here, you can see the variables of the category chess into there. And this is simply how we can map that to each other so we can quickly find it inside the engine. And then we just create our function, nothing special about that. And those are the few we will use today. So as you can see, those two are for the spawning of a chess piece. So we won't use that today, but instead use those two, and we will create them together now. Great. You can already see the functions here, which we want to include. And I will just show you through it. But before we do this, you might wonder, where is all this Stockfish code and stuff like that? So I already told you the stockfish.cpp is in here. And the fan parser we wrote is also not changed at all. It looks absolutely the same. But I included one part which you are not familiar with. And this is not the chess AI handler, which also looks the same, but the chessai.cpp. And the chessai.cpp shows you exactly what conversions we need to use them in Unreal Engine. And this is this file in here. So I also wrote this whole fan string, the parse fan stuff in there, just to show you how it would look like in Unreal Engine. But for now, we don't need that at all, so we can just use ours. All right, what is the convert to std string and convert to f string? So the getAI feedback, which we can now use, is not using the normal strings anymore, as you can see, but the F strings, which are used inside Unreal Engine. We also have the T array instead of a vector, and the bool variable didn't change at all, but the T array is, as I said, used as a vector. And here we can see actually both type changes. We have the T array instead of a vector and the F string instead of a normal string. We can still create the normal string, but then we have to use the convert to std string function, which I implemented for you in here. So what does it do? We use a string, which we know from C++, and then return an F string and convert the C string into the F string, which is quite a little bit of a workaround, but it works. Then we have the Stockfish response, which you already know, and the ChessAI handler instance.get ChessAI feedback, just as we used it before. Then we have the corrected fin, which is the convert to F string, the response fin. The best move is then also converted to a F string. The is checkmate is simply the same as before because Boolean variables doesn't change. And here we have something that is a little bit more tricky because we have to convert every move, which is currently a string, into a F string and then add it to the legal move, so the T array, because only then those two work together. And then we do the extract fan details, which we also had a look at the before, so just jump over that. Here, the extract fan details now use also F string, T array, and bool variables, and we instantiate those normal strings, which we then convert to the F string. In this case, I just wanted to show you how the opposite works. So we convert the F string here to a normal string, and that can be done using this convert to F string function here. No, sorry, convert to std string. Yeah, right. And then we just return the standard string together with the tchout to UTF-8 function and just convert this F string into the normal string. I know that sounds quite a little bit tricky, but just think of it that the F string, or which was an F string before, now is a normal string and nothing more. Then we have the legal move string, which we just added in there. And now we just use every move in legal moves and push back the standard string into our vector, which we already know. And the fan parser instance.extract fan details is now usable for us. So that's the whole point of doing this, because otherwise we would have troubles to use our previous build code. So that's why we changed between Unreal Engine C++ and our PlainC code here. And that's why I included those two functions, convert to std string and convert to F string. Now we get back the legal moves, and the legal moves are now empty. So those legal moves we get in here will be set to empty. And then we use the standard string, which we get from this legal move string here. And so the normal vector legal move string, and then change it, or no, add it to the legal moves array. So we get the T array together with the F string again. So that's the type conversion you have to keep in mind. And yeah, that's it for now. I guess we can go on with that part. So this is the only thing that changed, and everything else, so the fan parser.h, ChessAI handler, and the Stockfish is the same as before. All right, let's go back to the chessboard and let's quickly review it. So as I mentioned, we have the U hierarchical instance static mesh component. Why did we use that? It's simply because it can only have one type of mesh, but you can add as much as you want towards it, and it will handle them all the same way. So what do we do then? We have the field locations, which is a variable which we defined inside the header. So let me show that to you as well very quickly. Chessboard.h. Here we have the, sorry, I forget the name. It's field locations, okay? And the field locations are a map of a f string and a vector. And this is what we want to fill up now. So we clear any of the previous tile locations. And now for each field letter, we first of all get the field's letter, the actual field letter, by the field letter index, which we get from here. So that will be 0 to 8. Remember, our field letters are A to H, and that's how we can convert them into the actual column name, which can then only be A, B, C, and so on. Then we loop through the ranks. We have to inverse 1 and 8 because we place rows from 8 to 1. And that's just another kind of for function you haven't seen before maybe. And this is simply you start with the high number, and if it's bigger than 0, you just subtract 1 from it, and that's it. So you can use that function the other way around. Then we have the field name and the field letters. And the field letter is then combined with the f string from this integer. So we convert that integer, that number here, into the f string and combine those two together. So for example, we end up with A8 and stuff like that as the field name. We also have the field location in there, and that's a vector. And we determine that by calculating the field location by the field letter index and the number. And this is done like here. So we have a vector offset, and that is minus 450 and minus 350, and 0 in the z direction. And I will quickly show you why this is the case. So when we go back into the chessboard, and no, sorry, not the chessboard, the chess map, right here. It should open up in the background, right? And now we have those fields placed somewhere around here. And as you can see, the origin of our chessboard is right here. So we have to go down minus 350 and into the x direction. You can see that already. We are looking onto it from the z-axis. So that's also something which is quite unique in Unreal Engine, that the z-axis goes upwards. And here in the x and y direction, we have to go down minus 350 and minus 450 into the x direction. Actually, my bad, it's this direction, minus 350 in y direction and plus 450 in x direction. So we end up on this field here, and we can place it right there. That's the field A8 in our case. Then we have the step size. The step size is simply how we move down here. So how far do we go down for each of the tiles? And that's 100 in our case. I simply scaled that so it works together. And then we have not this one, that one. And then we can calculate the field location by using the offset plus the number index times step size. So in this case, this is our field offset up here. And when we want to do the next field, it's this point plus the step size. And this point would be this point plus 2 times the step size, and so on. So we actually end up with creating a row here very, very easily. All right. Then, calculate field location. And then we calculate the field location of y, also using the offset and the letter index in that case, times the tile scale. That's just to change it to a specific scale so it fits perfectly in. And then return the field location x, the field location y, plus the z offset. And the z offset is simply how far over the board it should hover. So we don't want it exactly located at the same height of the board, because then we wouldn't see it, but a little bit above it. All right, let's go back into the code down here. And we have the field location clear now. So we know what vector is now located inside this part here. And now we just simply add it, so it gets combined. We have the field name and the field locations added towards our field location. And now we could search for A8 and would get back that type of field location. Then we have the vector tile location. The tile location is simply the field location in X, Y, and Z direction minus the offset. And then we have the dummy rotator. Why is this the case? In Unity, for example, you use the quaternion.identity. Here you use just a dummy rotator, or you put that vector right into there to create a transform, because a transform always consists of, let me see if this is shown up here. No, it doesn't. Okay. But transform always exists of a rotator, the vector, and the scaling. So that is how you can distinguish a transform from each other. And then we have something which is based on mathematics once more. So we simply have the field letter index times 7. So we end up with the right letter in the right direction and add the number to it. So basically we fill up this part like here. And then we simply move down those rows and create them step by step, each one step after another. And when this number is equal to 0, then we have light tiles added towards it. So at the tile transform location, so this is not just the location, but the rotation and the scale as well, we add one instance to this U-hierarchical instance static mesh, and we have them then located inside the light tiles. Otherwise, we have them inside the dark tiles. So basically, just think of it. We iterate through it row by row and just check whether or not our index is equal to 0 or not. If it's equal to 0, we add it as a light tile. If not, we add it as a dark tile. And what we end up with here is simple to show you. Let me open up my project. We end up with a checkboard pattern, which we have predefined. So let me show you what the hierarchical instance static mesh actually does once it has loaded. And right, we're in the living room scene, I guess. Right, we're here. Let's go into the chess map. And as you can see, here we have our checkboard pattern. Very quick reminder for all of you who were not able to control the Unreal Editor with Visual Studio, no problem. Just keep in mind you have to always press onto this logo down here to always recompile your scene. And once it will turn out green, everything should be done and you will also see the checkboard pattern. This hierarchical instance static mesh, which we decided the material earlier on, we can do that very quickly by going on to either that blueprint here and going on to the chessboard here. Now we can change that. So let's quickly go onto the event graph to not have anything blurring your vision here. And you see this is the chessboard tile we have here. And the dark tile has another material. So when I change that to color, for example, and this one to white color, and what you can already see is that it changed it. And you can also see I can now move the board around because this pattern doesn't change at all. But I changed the color of my pattern, and I can do that with the light as well. Let me check the chess piece light, that's fine. And you can see we now have a checkboard with white and black patterns in there. And that's simply because we changed the material inside of it here for each of those chessboard tiles, which are just meshes inside our hierarchical instance static mesh component. Let's switch that quickly back to light wood and dark wood, because I like wood way more than the black and white part. And now you can see we have our checkboard once again. Let's quickly check our current project progress again. We have now seen where our previous code, so the basics in Stockfish and C++ console program code went, and we also have spawned the chessboard pattern now. You've already seen how blueprints are used, and next time we will do the chess piece spawning before we advance to the moving itself. Phew, that was quite a journey, wasn't it, huh? I know this stuff is very intimidating at first sight, but trust me, you'll get into it very, very quickly, and it gets easier from here because, first of all, I had to show you how to even navigate through blueprints and where all this stuff is located inside our project. We haven't had a look at the game mode itself yet, how this is programmed and stuff like this. But once you understood that blueprints are just a visual art of coding, you will definitely get into it very, very soon. And yeah, so I just keep it here for now. I hope you had fun. You know I did. And yeah, see you next time. And I'm already looking forward to spawn the chess pieces together with you. Have a nice day.